All right, kids, let's try the number 25 in GeoGebra. So x squared minus y squared. Nice. And let's plot the point. It's 1, or I think it's negative 1, 0.5, and a of negative 1.5. And so that point is way down here. So let me kind of zoom in a little bit so we can kind of make this a little bit larger and turn it. And so let's do this first question. I'm not going to add any more grid lines to this. You could do it, but no reason to, because they've got grid lines on the surfaces. That's okay. A line from negative 1, or 1, 1 to negative 1, negative 1. So that would be called a curve command. And it kind of works the same way. I would go 1 minus 2t, comma 1 minus 2t, comma 0, and t will go from 0 to 1. So there's that segment that is actually entirely on the curve. In fact, if I probably made my t variable go from, say, like negative 10 to positive 10, that line would stretch out even further along there, but that does lie entirely in the curve. This is actually called a ruled surface. I could make this surface out of nothing but straight lines. So let's go to the next one. Let's find the tangent plane. To find the tangent plane, I'm going to need the partial derivatives. So the derivative of A, that's the name of my surface, with respect to x, and the derivative of my function A with respect to y, and I'll hide these surfaces, I do not need them. And if I wanted to write the equation would be the partial derivative of x evaluated at point A, and it would be x minus 1, plus 1. And then it would be a plus the partial derivative in the y direction evaluated at A times y minus 0.05. No, 0.5. So I've got my plane. It looks like it's kind of lying correctly. Now I need to, I may need to move it up or down a little bit, but let me go equal to z and see what this does. It does not like that. So I'm going to leave it like that and see what happens. And I think what I'd probably need to do is I may need to move that up, and I would probably need to move it up by whatever the y-coordinate is. So I'm going to go over here to the end. I'm going to go plus 0.75. And there it is. Now, it's as weird as a tangent plane, because as a tangent plane, part of it lies below the surface, and part of it lies above the surface. It kind of depends where you are. And my feeling is I'm probably going to ask you about like those intersections. Like, where does, like, let me make this intersection of two surfaces, like this and this. Like right in there. And you won't even let me do it, because that graph is a graph, not a surface. But a little bit easier to do in GeoGebra than it would be in that CalcPlot 3D. But pick one, man. You need to try to make all this stuff you can in one or the other.